Hey guys, welcome to Sardine Programming episode 4. We are going to fix the controller up because the controls they didn't feel right last time I recorded. I noticed it. And we're also going to clean up some of the physics inside this update method. We're gonna subclass this fish a bit more. We're gonna add some more fish, hopefully, and differentiate between the fish that the player controls and the other fish in the sea because they are going to control a little bit differently. I will talk about that when we get there, but let's fix up the controller first really quickly. Um, Whenever you make a controller, or whenever I make a controller, I like to extend this input adapter because I can choose which methods I want to override. However, update is not a standard method of the input adapter in libgdx. However, I feel almost always that it's necessary to have an update method and update your controllers. And I think this is one of those cases, even though I am a little bit reluctant to add it. So we are going to do this using an update method instead. Let's go. It is of course always not advisable to have these hard-coded values inside the controller, so instead we are going to put that in the settings here. Maybe this part of the settings is related to the controls, maybe not. Player acceleration, 0.4 is fine for now, I feel. Now we just need to update our controller here, and then we are finished. Controller update, yeah. There we go. Let's try it out. It won't really let me use left and right at the same time yet. Maybe this set acceleration approach isn't the best. Also, it spawns a lot of new objects all the time, so we can keep that to a minimum while fixing this bug, because I do want the vector to point diagonally if both up and right, for instance, are pressed. So in the fish we can grab the acceleration object, set acceleration, we can get it instead. Oh wait. We can add the acceleration instead of setting a new acceleration and then setting the length of the vector to be the player acceleration. So the player will always accelerate at the same rate independent of what way the vector is pointing. So this is the up vector, so it should be 0, and then whoops, and then the player acceleration setting on the y-axis, and then we can normalize it, and then normalize it to make the vector length 1, and then scale it to make it the length that we want. I'm trying to figure out if this is correct. Yeah, I believe it is. Awesome. So now we also avoided creating these new vectors all the time. That's great. Can't help but feeling like this is gonna be prone to bugs. It's gonna be interesting to see. Okay, let's try. That's not too bad. Doesn't feel too bad. At least. Even though I'm trying not to have any... Yeah, you can do this, but I mean... You can do that in tons of games. It's a cheap controller. Next thing we are gonna look at is the physics for the fish in here. We're also going to subclass the fish a bit. Let's do that first. The player fish is gonna be a type of fish that has drag. I don't want the other fish to have drag because I want them to follow a path specified by a parametric function or acceleration according to a parametric function. So, superclass the fish. Let's go. Let's fix the update method in here. The velocity is completely fine. Each second we want to take the acceleration and scale it by the time that has passed. And then we want to... this drag here, however, we want to remove. Don't want drag on a normal fish. The state machine has... I think it has got to go. Yeah, it's got to go. The player fish, we are now overriding the update method. So underneath what is called for all fish, gonna have the state machine. We can do get acceleration instead. If we are switching to the idle state in the superclass, we want the animation timer to reset. That is given for all fish. Now in the player fish, we don't want to touch these fields directly. Actually, state should be not protected anymore. It should be private, because we're going to touch it from this method down here that is protected instead. And then that'll take care of this extra animation timer complexity. The reason I'm moving this is because the player fish is the only fish that is going to have animation dependent on acceleration, because some of the other CPU fish are going to move at a constant speed, for instance, and that's gonna look ridiculous if they don't animate. So it's not given for all fish that acceleration should always be used for animation, and we'll see why in a bit. Let's go back to this normal superclass fish. We can remove this state machine, and we can, if the state is swimming, we're gonna update that animation timer. The phasing update should also be used for all fish. It goes first, and then we are collecting all the physics code down here at the bottom. The velocity, yeah, that looks fine. Yes, I believe it's fine. Now for this drag, I really want to express it differently. I want drag to be a small number, a really small number, and then instead of doing velocity times drag each frame, we're gonna do velocity times drag times delta. And then subtract that from 1. So this is going to be a really small number depending on the delta, and then when we subtract that from 1, it's going to be close to 0. It's going to be farther from 0 if the delta is huge, so that's fine. We get a larger value if a larger amount of time has passed. That's fine. And then that's what we multiply with velocity, a number close to 1, so that it goes down proportionally to the time that has passed. That is what we want to do. But we want that complexity in the player fish, because the CPU fish are going to be controlled differently. So right beneath this acceleration code, we are going to get the velocity. Maybe I should call this super method in the very end, actually, because it does update the position of the fish, and I definitely want the drag calculation to be taken into account. I think we're gonna need a few more methods here. This bit here should be update position, maybe. And then this line right here, I really want to put that into another method so I can override it in the player fish object, so that I can impact the velocity and the acceleration before the position is updated. Yeah, let's do that. It's going to be a private void because I don't want anyone to override it. This is going to be protected though, because I am going to override it. Just going to do it physics calc right now. Just your name. Now I can call the super method in the beginning of the update method and still feel fine, because I can override the physics calculation. And it is the velocity I want to manipulate here. Do we have a get velocity? We don't. Great, so in the player fish we have the physics calculation, and we just want to add some drag to the velocity. However, only if we're not swimming. We have a set state, but we don't have a get state. That's weird. We're just slowly scaling the velocity down if we are idle according to the drag that we define in the settings. Maybe the drag should be a little bit bigger. Let's see how it plays. Doesn't play at all. Oh, that is of course because we did not initialize it as a player fish, perhaps. Perhaps. Or maybe we did not apply the physics calculation. Maybe that's why. Yeah, that's why. Okay, the controls are really floaty. I'm not touching anything. The fish is idle and it just keeps on going. There's not enough drag in this water. Let's turn the drag up a little bit and see what we can, if we can get it to play a little bit nicer. No, the fish just keeps on going. Oh, that is of course because it's not a player fish. The player fish is the only fish that has drag. It does come to a full stop, but it's not immediate. It's still a little bit floaty. But maybe that's a good thing. Maybe that makes the game difficult. I don't know, I think it's okay. Okay, one thing we also gotta do is tell the world what fish is the player fish, because the player fish is the only fish that's gonna loop around when it exits one of the sides, and that's the world's job. So we're gotta let the world know what fish is the player fish, so we can have special rules for that. It's still gonna exist in the maybe not. Maybe it's not gonna exist in the fish list. Update fish, add fish. We'll get these player fish. It's just a regular fish. Great, I believe we are done cleaning up now. Let's try and add a fish that will go in a straight line. Let's call it a straight fish. Make it extend fish. Should have a few more parameters. Should have a vector 2 in the direction it's going. I'm gonna set the velocity constant to the direction, and then normalize, and then multiply by how fast we want a fish to go. At the most, I did not specify that for the player fish as well, but we are going to have a speed limit. Let's call that max velocity and make that maybe 4. There we go. I believe believe that's fine. Let's add one of these fish to the game screen now. It's gonna be a StraightFish. For now, we'll just slap the same animation sprite on it and maybe make it start at 0f10 and make it go left. Now right. And add it to the world. Oh, in the game renderer, we should have, of course, when we get the fish. Yeah. Should also make the player fish available. Wow, that fish was really fast, but it did what I wanted it to do. Yeah, that's fine. Maybe the StraightFish should animate as well. Let's see if we can make that happen before we call it a day. Maybe we should just make it swim all the time. There we go, that's beautiful. And let's make the max velocity even smaller. There we go, a fishy friend. Can make it go a little bit faster. Great, so this fish has a constant velocity. That's fine. Let's before we stop for the day, let's see if we can get this fish to swim in a different trajectory. See if it still works the same. Can try diagonally. Yeah, that seems to work just fine. Great. Okay guys, that was it for today. Next time we are maybe gonna clean some of this up, hopefully add some more interesting fish. Thank you for watching my video.